This is my video explanation for the test corrections for exam 1. For problem 1A, originally I had increase, increase, not change, decrease, increase, whereas now the correct answers are increase, increase, decrease for the last three. And because as the equilibrium conversion decreases, that means the forward constant and the reverse rate constants, both of them will also decrease. The forward rate constant will be faster than the reverse, but they are still decreasing in time. For 1B, I had the original correct R equation, but for part B of B, I guess, I had RB was wrong for myself. I had the square root of KFCA. Now I understand that this is just negative 2R based on the equation given, and then RC would also just be R for this equation based on the chemical equation. For 2A, I got 1C completely right, so I'm not redoing that one. For 2A, I originally had the decrease, increase, and increase, and those are correct. I just had the problem with indicating that the range has negative kinetics because of how the graph looks and how the rate is changing throughout time with this graph. So I had positive with now negative. And then also for the final part, concentration varies with length in a PFR. CSTR is continually mixed over time is the correct answer for the last part. I had got 2B correct. 2C I got wrong. These just need to be your mole balances or your mass balances based on, technically mole balance because we're in moles right now, based on the reactant that we have. And then because the graph is in 1 over negative RA, we use our fractional conversion to plug values in and substitute. And this is able to give us our volume for our CSTR, which is 20 liters. And then our PFR, we do the same thing, sort of. We solve for negative 1 over RA and then integrate with volume in the conversion. And then we are able to solve for volume for PFR, was 120 liters. 3A is the water gas shift reaction problem. Originally, I didn't have my spice table all the way correct. I didn't have it in terms of the right numbers, I guess you could say. So for the correct change, this is how you do the spicy table, and I understand that now. The delta G is still the same, delta G, delta F, and you get K naught or right here. Make sure your units are correct. And then you're able to get the total reaction stoichiometric coefficient is 0 based on the equation. And so that means Ka is then equal to Ky. And then you can plug in for Ka naught and solve for 1 over T. And then that gives you a temperature of 523 Kelvin. This problem makes a lot of sense now. And then the site balance one, they stated they gave us our rate limiting step and our quasi-equilibrium step. Then for the quasi-equilibrium step, we solve for our O star, recognizing these K1s and K2s. And then moving forward, you just want to not have any stars in your final equation. And then you just basically do almost linear algebra, plug it in, solve through the equation, making sure everything's substituted, and end up with the final answer down here. And then finally, for the extra credit, the correct answer is PFR, then 0.1 up to a conversion of 0.1, and then put a CSTR with a total end volume of 35 liters. This is solved the same way as the volume equation for problem 2C, but this is now the correct configuration for the extra credit, and that is my explanation.